All right, let's go ahead and get started. Good morning, everyone. Thank you for joining us today for the Oasis Sales TriLogic sponsored webinar. Did you know design rule routing automation can lead to shorter design schedules? Just a quick couple overview things real quick. Oasis Sales is our value-added reseller for meander graphics in the Midwest. If you have any questions about the tools that I'm talking about today or any other products, feel free to go to the Oasis website. You're going to see it at the bottom of all the slides as we go through this presentation. Feel free to ask them any questions or contact them regarding any questions on the tools that we talked about today. And TriLogic is the value-added reseller on the East Coast. And if you live in their area, please contact TriLogic with any questions or help that you need with the meander graphics software. Just a quick map of where everyone's located. Again, Oasis is in the Midwest territory and TriLogic is on the East Coast territory. And again, here's their website down here at the bottom, www.oasissales.com and trilogic.com. All the webinars that we do, we also post on our YouTube channel. You'll be getting a follow-up email actually with the YouTube link to this webinar for you to review in the future, pass around to colleagues. So feel free to go to the Oasis Sales or TriLogic YouTube channels, and you'll see playlists for the Did You Know, Tech Talk, and other valuable webinars that we've put out there as resources for you as our customers. The next Did You Know webinar will be Thursday, October 11th, and it's a mixed technology and RF with PADS Professional. Again, we're available to help you out anytime. This is my contact information. You can also email or go to the Oasis Sales website or TriLogic website for contact information for getting assistance. And just so you know, if you'd like to ask any questions during this webinar in the GoToMeeting control panel, feel free to type in a question directed towards me. I will try to answer some of those as we go through the presentation, but more than likely I will wait until the very end to answer any questions that you may ask while we're talking or while the presentation is being conducted. All right, so let's go ahead and get started. Again, today's webinar is Did You Know Design Rules and Routing Automation Can Lead to a Shorter Design Schedule? So what are some of the benefits? Well, I should have had a slide here. What's some of the benefits, real benefits of setting up design rules and doing automatic routing is one, a lot of customers that I've talked to over the past few years and even in the past still continue to route boards manually. In other words, they don't set up design rules, they're just using defaults. They're going in and they're point-clicking routing everything on the board. And with today's technology and the tools, you're not taking advantage of what you have. Today I'm going to be covering the PADS integrated flow along with PADS Professional. The reason why I'm doing that is both of these applications or PCB design flows for Mentor include a tool called the Constraint Editor System, or CES. The advantage of using this application is it's very much like using an Excel spreadsheet. So it'll be very familiar to you in the environment, copying and pasting, dragging and dropping design rule constraints, having a navigator window to navigate around into the different types of constraints. And you'll see that here during the demonstration. So again, the big advantage of moving to the integrated flow with the PADS tool flow, which you can do with PADS Standard Plus licensing, is the fact that you gain this constraint editor system mechanism. Unfortunately, today I'm not going to be going over the PADS standard basic default design rule functionality. There's not much to say there. It's just default design rules and class or net rules. It's pretty simple and basic. The interactive routing, fan out, the automatic routing stuff that I do talk about, you can take advantage of in that pad standard flow. But from a design rule perspective, I'm really going to be focusing on the automation that's available in the more advanced versions of the pads flows. All right. Another advantage is you can pass trace length information from the PCB back over to the schematic, which is something you cannot do with the original pads classic flow and pads logic. That information can only be viewed in the PCB tool. Big advantage here, again, with pads designer and using CES, the electrical engineer, if they're not doing the layout, can review length information, and if everything's met the requirements based on the design rules in the CES environment at the schematic level, they don't have to open up the PCB layout in order to do that. Schematic designers can also define 100% of the full constraints using the constraint editor system. So you're not, if you're a PadLogic customer, you're not constrained to just doing default rules, classes, and nets. I can do differential pair, well, I can do differential pairs in logic, but there's automation for setting up differential pairs, but I can go in and set up all my pin pair definitions if I'm doing some complex routing. So I can define all my topologies, and then I can set up, rules based on layer and everything that's required for those complex designs. You can also review stack-up information as well in CES. All right. So what are the advantages? That's some of the design rule topics that we'll be showing here during the demo. But what are some of the benefits of interactive routing? Hopefully everyone out there is using the interactive push and shove routing capabilities of Pad Standard, Standard Plus, and if you're a professional customer, it's pretty much kind of forces you into that environment, kind of like Pad's router does actually. But the interactive routing really simplifies the process of routing a board. A lot of people say, well, it moves the stuff all over the place in other locations. You can control some of that by using locking mechanisms. But in general, it's been my experience in doing printed circuit board design that I can route boards 30+% faster using interactive routing than doing point and click routing in the pads layout environment. So if you're not using interactive routing today, hopefully what I show you here today will convince you otherwise that you really should be doing some of that and taking advantage of what the tool is providing to you. Some other things with interactive routing is being able to just do edits. If I have to put in a trace, it's always difficult when you get near the end of a design and the last couple traces end up taking, hours to put in, unlike the first ones you put in, which only take a couple minutes. I remember, back when interactive routing wasn't a thing, you'd have to go in and rip up traces and put new ones in, move things around a lot. It was just very difficult to make modifications, where today, with push and shove, you can literally just grab one of those nets, assuming there's room to push and shove stuff around vias. You can just kind of drive it through a channel if there's given spacing there available, and the tool will take care of all the pushing and shoving of nets. Now, if you really want to control what gets pushed and shoved around, you can do that by locking down nets. And again, I'll kind of show some of that here in the demo. Probably one of the biggest reasons to use interactive routing, though, and auto routing, I'll talk on the next slide, is the fan out functionality. I still talk to people that are putting using multi-layer boards with internal power and ground planes, and they're still going in and drawing in traces and dropping vias for every single fan out net, when that is 100% not necessary. The routing technology that's available today does a very good job at fan outs, and I can do it in a couple seconds, which saves me a tremendous amount of time, again, in my printed circuit board design. So again, modifying traces as well is a lot easier with push and shove technology. So I can grab one net and have it push other ones. I'll see some of that as we play around in the demo here with cleaning up some of the routes that I put in. And then of course there's auto routing. A lot of people don't really want to use auto routing. Some of us older designers may have experience with auto routing, so you're a little more apt to use it, but a lot of younger designers, you know, are kind of shy away from it because they may not have gone in and defined all the design rules. They've tried it. It doesn't do the result look like what they expect it to look like. But that's what we're talking about today, being able to set up constraints to help us produce some of the routing that we want and take advantage of this auto routing technology that's available in the tools for us. All right. Now, I would never really condone auto routing 100% of a board. In fact, I never have in any design I've ever done either. Most people will like to interactively or maybe auto route just a group of nets and then go in and clean it up a little bit and then move on to the next step. And that's basically how I end up designing boards. And most of the people that I know are pretty efficient at board design do it that way as well. So using auto routing from a interactive perspective, which I'll show in here, can be very advantageous to your design flow. Okay. And then lastly, one of the things that tools provide is interactive length matching capability. So if you're doing any trace length matching, differential pairs, you can do that a lot faster by taking, again, advantage of the tool, and it's all available to you there, at least in Pad Standard Plus and Pro to do that. All right. So let's go ahead and take a look at some of this. I've got a couple designs open here in both applications. Let's start out with, oops, I don't want to go to Pads Professional first. Let's start out with the Pads layout flow. I'm going to call it Pads Classic because it's a little bit easier to understand that way when we throw Professional in there. But so to take advantage of everything I want to talk about, you really need to start using or be using Pads Router. All right. Pads Router is the environment that was introduced many, many years ago. It started out as just an auto routing tool, but it's migrated into a lot more than just that. I mean, now I can place parts in here. Just a quick example of that, if I select a component, you know, I can pick up this component and I can move it around. Obviously, I can do all my routing in here. They just recently added in the last release plane flooding capability in here. So if you draw your shape in the layout tool, you can come in here and it auto fills in all of your planes for you and does you know, interactive flooding while you're routing. All the flood will automatically change while you're doing routing. So I'm not going to cover that here, but just so if you were not aware of that, in VX 2.3, you should definitely try and take advantage of that. Open up a design that has planes in it, bring it in, you'll see it will automatically flood. If you go into properties options here, actually, you can control it if you don't want to use it for some reason. But if you click on the flooding section here, there's enable dynamic copper pore healing. Basically, that is, it's going to dynamically flood your plane, and then it's going to automatically put voids and stuff in as you put vias and traces in. But this is kind of how you can control that. So just a quick little tip and highlight on that one. So let's get into defining some constraints. All right. So while I'm in Pads Router, Pads Layout, or Pads Designer, by the way, if you're a Logic customer, unfortunately, you cannot take advantage of this rule constraint stuff that I'm talking about in the CS environment. Is not available. If it's something that looks interesting and you think would be beneficial to your flow, by all means, you have the, especially if you're a Pad Standard Plus customer, you have the integrated flow and you have the capability of starting projects in Pads Designer and using the same functionality that I'm going to be showing here. So to enter the rule constraint environment, up here on the main toolbar is the constraint editor button. You go ahead and click on that. That will open up our constraint editor tool which I can have running at the same time that I have pads layout and router running. So if you have dual, triple monitors, you can drag this screen off to another screen. And then in here, I can go in and see and set up all my design rules and then update my design and continue working and come back and make adjustments and so forth. All right. So just a quick run through of the environment. We have our net class section over here where I can set up classes of nets. This is very similar to how you set up classes in pads in general. The only difference is you're not physically putting the spacing constraints on the class. You're setting up your layer based rules, what layers I'm allowed to route on, and my trace width information, and for differential pairs, my differential pair spacing. That's really all you do in the class. From there, we move down into the clearances. The clearances are basically a container that we give it a name. Again, based on layer, you can specify all of your copper spacing requirements. These are your physical design rules that you use in the tool. All right. Now, the advantage here is I can create these different groups of clearances, and then I can use them between my classes. So like in Pads Classic, if you had the advanced row function, you had to go into classes. Then every class you made, you had to set up a set of design rules. And if you wanted to change one of those set of design rules, and it happened to be the same for 3 other classes, you had to go into each one of those and change them. With the CES environment, I can set up my classes, then I can come up here to, not general clearances, the class assignments, and with these different clearances, I can go in and say, okay, my analog to analog is going to use one set of rules, and then my analog to class or clocks is going to use another set of rules, and I can reuse that over again. So this analog class of nets to differential pairs is going to use this rule. So you can reuse those design rules between any given classes using this matrix. So I can use that same set in multiple locations. And then if I adjust that rule set once, everything automatically sees that change. So that's a huge advantage and time saver when you're going in and adjusting rules. All right. By the way, for those that don't know or haven't really used class definitions, classes is in a very efficient way to set up design rules by groups. Now, if you're only doing design rules for the entire board, then obviously you would just use the default stuff. But if you want to segregate things like power, like you should always really have a power class in your design. So in fact, I'll create one here right now. We'll do new class and we'll call this power. All right. And then once I've created that class, I can go in and I can do my net assignments for that. So I can search for ground and I can search for some of my other power nets, which are these 2 here. Click OK. And now for that given class of nets, I can define what the trace widths are. So instead of me going in and routing everything at, say, 5 mils, and then for my power nets, I have to keep changing the trace width to 10, 15, 20, I can just set up a class rule for it or a net rule if you're using the Pads Classic flow. And every time you automatically start routing those nets, it's doing it with the right width. Okay. So I'm going to set these to 15. Now, you'll see what happened here is, again, in CES, it's a spreadsheet type environment. Up here at the top is you get a tree view of your classes or your nets, and you'll see that as we continue to go through here. But for this power class, when I changed the master item at the top, everything underneath adopted that value. Okay. Now I obviously can go in and change stuff manually or between different layers. So I could have this 20 here and 20 here if I wanted, or we'll undo that using the Control Z key. I could have the bottom maybe at 20 and the top at 15 or something. Okay. And then using the class, we can also control what layers we're allowed to route on. So technically, I don't need to route any power stuff on layers 2 and 5. And I really shouldn't be I'm going to be using planes, so I'm not going to really be routing anything on 3 and 4 either. All right. So to go a little bit further here, I can set up different clearances for those power nets to everything else. Let's say I wanted to do that. Let's create a new clearance group. All right. And I'll call it power again. And these don't have to be the same by any means. I could do like what I'm doing here. I could come in here and rename this and actually call it, say, power to all. All right. And now, again, on each individual layer, I can come in here and I can define my physical spacing constraints between any given object on the board. All right. Just to explain these, so we have trace to trace, pad, via, SMD. We have pad to pad and via. And then we have via to other vias and surface mount pins. And then we have those same objects to the board edge, and we have those same objects to copper shapes. Those copper shapes being physical, basic solid copper and plane areas. All right. So now let's say for all my power nets, I want a little bigger clearance to pretty much everything on the board. So I'm going to change these to 10. Let's not go that crazy. Let's change them to 8. Now, instead of me typing in 8 all the way across there, what I can do is, just like in Excel, I mentioned this is like using an Excel spreadsheet. I can grab this little square down here in the corner like in Excel, and I can drag that across. And as I do that, it fills that in. And obviously, I did it at the top level, so it fills in everything below. All right. So there's our power clearance class. Now I could go into my clearance settings, and then I can come over here and say, okay, power to everything is going to be this. So for every one of these additional classes I have in my design, I can assign it to all that same group, and then to everything else that's not part of a class, I can assign it to that as well. All right. So there, now I've used that class of clearances against all these other, against everything else in the board. Moving down into the constraint area, this is where we get into all of our length matching, high speed, topology driven design rule requirements. So if you're doing differential pairs, length matching, you're going to be setting up constraint classes. All right. So you can see I already have some set up here, but I'm going to add another one, and I'm going to call it, we'll just call it address and special. I'll just call it SP. All right. And then we can assign nets to that. So I do right click, assign nets, just like, this is kind of like creating a net class, except now you're only doing it for high speed constraints. Again, you can make these the same name, the net classes as constraint classes if you want, but they don't have to be. All right. So if we come down here to address, I'm going to grab these guys right here, push them over and click OK. All right. So now if I click on that, you'll see my list here is abbreviated from all, which shows every single net in the board. Now I can look at just these address nets. All right. In here, it's giving you some cool information. It tells you what level of hierarchy the nets are at, how many pins are on the net. Have I assigned a class to these nets, which I haven't yet. So actually I should come up here and create a new class and call them address special as well. Oops, I didn't want to do that under default. Let me delete that. All right, and then I want to assign nets to those. There we go. Now when I come back over here, you're going to see that the net class for all those nets is showing up here because I've assigned it in that tree. All right. I can set up topology information if I want. So I'm actually going to end up doing that here. I'm going to make this a custom topology in this case. And if I expand out this net here now, you'll see all the pin pairs show up. Until, if I left that at MST, like let's say I turn number 6 back to MST here, discarded. topology definition stuff that may have happened, and I expand that out, you'll see I don't get all of the pin pair information. But now I have the pin pairs, and I can now go in and define rules based on each individual pin pair of that net, which I am going to do in this case. All right. So if we scroll over and look at some of these things here, I can specify stub length. This is if you fan something out, how long the vias can end up being, what our maximum vias can be on a particular net or group of nets via the class. Of course, we have our basic length matching, so I can put length requirements on, the entire net. That would encompass all of the pin pairs that are available to me. Or I can come in and I can put individual requirements on pin pairs. So under this matching section, well, even under length match here, you can see that I have the pin pairs have available that, but I'm going to do matching actually. So I don't necessarily care too much how long they are. All I care is they're all within a certain distance of each other. So the ones I'm really concerned about in this case here are these P1 to U1 net pin pairs. The other ones I would probably put rules on, but for the simplicity of this demonstration, I'm just going to concentrate on those for now. So what I can do is I can put a name in here. Like I can call this P1U1. Oops. P1U1. All right. I can put a tolerance on that of, let's say everything needs to be within, 10 thousandths of everything else. So now I can copy this using Control C, come down to the next pin pair, P1U1, paste that in, you'll see it automatically adopts the same tolerance. And then I can continue to do that for each pin pair that I want to do this to. All right. And now if I change the tolerance on any one of these, it will automatically update for everything. So if I change that to 20, you see all of them change to 20. So let's go back to 10. All right. Some other automation that's available in here is the ability to auto-generate your differential pairs. So if I come up here to edit differential pairs auto-generation, this will bring up a dialog box, and now I can have it automatically search for the differential pairs in my design based on some suffix scheme, right? So in my design, I'm using underscore P and N, and then I can hit the down arrow, and you'll see, oh, there it picked up all the nets that have the P and N on them. All right, and then you can, if you don't want to make one a diff pair for some reason, you can deselect the checkbox, but it has them automatically selected. I can go ahead and hit apply, and now if I go look back at my default constraints here, let's see, there's the differential pairs were automatically created for me. So there's the individual nets as I would have seen them previously, but now they show up as a defined differential pair, okay? And let me go to my differential pair group here and assign nets. Currently, I don't have anything in there, but I can go find those. So down here, there's all the nets right there. We can add those over now into that class. Of course, I could have done that all through the spreadsheet. I don't have to use that environment. So if I come back here let's do it in all. Scroll down to those differential pairs again. What I can do is I can select these individually. I'm holding down the control key to select these, and then I can tell it that I want to assign these to a constraint class or a net class that I may have already created. So in this case, I'm going to assign these to my diff pairs constraint class. And there it is. Click OK. Now if we go into diff pairs, you'll see I have those listed out. Now I don't have to look at everything else in the table to see those. All right. Now in here I can, just like everything else, I have all the same constraint capability. I can set up topologies if I want. These are only 2-pin nets, so there is no topology there. I can set up my VM maximums, min-max lengths requirements, matching requirements, separation distance for my differential pairs. All right. So this is where you could take advantage of, say, your hyperlinks tool in your standard plus or pro suites. You can open up the hyperlinks application and go in and play around with the stack-up editor, figure out what your separation distances need to be in order to give you the impedance you're looking for. So in this case, I'm just going to go with 5. Make it simple. All right. And then back on our differential pair net class, I can also specify the differential pair spacing by layer. All right. So let's say the spacing needed to be 8 on the external layers, and let's say on the internal layers, I can't remember if it needs to be close. I think it's closer together. Let's make it 6 and 6. And again, we're not routing on the power plane layers, only layer 2 and 5. All right. So now I've set up my differential pair rules, constraints. I've set up some classes. I've set up some length constraints rules for some pin pairs. My design. Let's go off and now take advantage of the routing technology in Pad Router to route these nets. All right. So we come back over to Pad's Router, and before I can start doing anything, I need to synchronize the constraints from the CES tool into Pad's Router. So down here in the very bottom right-hand corner, I'm going to make this window a little smaller, but right down here in the bottom right corner, there's a little indicator light letting you know that you haven't synchronized yet. You can simply double-click on that little LE or button there, and it will go through the process of synchronizing your CES constraints with your physical design, and now I can go in and start doing things. So previously I didn't show this, but I didn't have any differential pair assignments that showed up here in the tree, where now I do. All right, I didn't have any match link pin pair groups previously, and now I do. So I can see those, and you can use that for highlighting in the design. Okay. Oh, looks like I ended up picking a net that shouldn't have been in there. So let's concentrate on these 4 nets right here for right now. All right. So actually, before I end up routing anything, I want to, one of the first things we usually end up doing is fanning out or putting in our power ground vias usually, so that they're already in place. They're actually very important to the design's functionality. So I'm going to go ahead and do that in the design in a couple different ways here. All right. One, I'm going to just choose a component and do it interactively. So if I set my filter for component and I right click, and in the right click menu here, I can just choose fan out. You see the tool will automatically fan out those power and ground pins. And the nice thing there, is it used that 15 mil trace width that I defined in my class. So instead of me having to worry about coming in and modifying that, it's already set up exactly the way I want. The tool did it like how I would have done it. So I can move on to doing some other parts. All right. Now, a BGA, one of the things we do have a little different constraint capability in the PADS Classic flow versus, say, PADS Pro when I get over there, is the ability to assign component-based design rules, which we can take advantage of, especially when fanning out a tight pitch BGA like this one here. So if I select this guy and do properties, you'll see on the properties dialog box, I can do things like I can set up trace width coming off the ball pad to a via. I can change the pad entry just for the component. But more importantly, in this case here, and what I would mainly recommend using component rules for is for fan out purposes only. I can set out what ends up getting fanned out. So I can tell it I want to do the plain nets, single nets, and I'm even going to go ahead and do unused pins in this design. All right. I can choose my different BGA fan out pattern capability. This dialog box here is actually going to look very familiar when we get over into Paths Professional. But I can specify other things like some basic clearances. And also another important one is my via assignments. I've already got a via that's sized properly, but I can come in here and I can choose a via that I know is small enough to fit between the pin pitch here. All right, so once I have that component rule set up, now I can right click this part and say fan out, and it will go in and fan out this entire BGA for me in a couple seconds here versus me going in and doing all of this manually. All right. So there we'll see it added power and ground traces in. It added some signal pins in here automatically for me. Okay. And if we come over here, we can do the same thing for this part, even though this one here, I can just use the standard design rules for in a tool. So, oops, actually it wasn't done doing the fan out. It's still in the process. Oh, there it's done. Okay. So the second way of doing it is I can actually go in, I can just choose a pin. So if I just want to choose a pin in the design to fan out for some reason, I can do that. I can just do right click fan out and it will drop one in just for that one pin. So if I want to do a decoupling capacitor or something like that, you have that capability. And then lastly, what I end up doing most of the time is you go into the options dialog box and you set up a strategy. And in the fan out strategy, that's the only thing I would turn on. And I would tell it I'm just going to do all nets, but I can add in particular components based on reference designator here if I choose to, decide which ones go first, make sure that is set up. And then we open up the auto routing toolbar here, which is this icon here opens up the auto routing toolbar. We get these icons right here. And then I can just go ahead and hit play, and this will go off and fan out every single power and ground pin, which is all I've basically set it up for to do in the design for me. Okay. If you want the application to do signal nets, again, that is possible. As soon as it's done here, I'll show that, but I did only enable it for power and grounds in this case. So it takes a couple seconds here to fan out this entire design, but it's way faster than trying to do this obviously by hand. Okay, so there it's completed. You can see it's fanned out this entire BGA, fanned out all my power and ground pins on my capacitors, so I don't have to worry about doing any of that work by hand. And you'll see it did pretty much the same job you did. All right. Now here's where I would need to go adjust my rules. So what happened here is the design rule was large enough that it ended up necking down to my minimum design rule requirement for this pin. So that's obviously a fault on my part for entering a rule incorrectly. Let's see, I had a question pop up here I'm going to answer real quick because it's related to fan out. So when fanning out, can I select a pin, have it drop more than one via? We typically use 2 or more vias. Unfortunately, no. In PAD's environment, it will only fan out one pin or one via off of that item. That's actually kind of where it's kind of nice to do stuff back in PAD layout, because in layout, once the fan out is there, and I did this quite often as well for decoupling capacitors and such, is you can select the trace and the via and you can copy it and then you can rotate it around, paste it in different locations. So I might manually draw these ones in, and then I would select them all, copy them, and then I would kind of go paste them around on different components that you want multi-drop vias on. But yeah, unfortunately, the auto router will not do that at this time. All right. So now I've got my fan out done on my design. Let's go do a little bit of routing here. So these nets here, I actually need to fan out, and I need to turn that function on. So all I did was double click to bring up the design properties dialog box. You can see I had a signal net turned off. So I'm going to go ahead and turn that back on. And now I can select these pins right here, and I can tell it to fan these out for me. So they're dropped in vias. I'm actually going to flip this guy over here. Oops, forgot to left click. And I'm going to flip this one over here as well. So again, a couple little things you're seeing here as I did that is taking advantage of interactive routing technology, just being able to move stuff around, and it does all the work for me. All right. So let's go ahead and we'll route these in. Let's go to layer 2 here, and I'll open up my interactive routing or route editing toolbar. This first icon right here is the interactive route, or I could have just hit F3 on my keyboard and started routing that way as well. I'll go ahead and start routing. Let's see what happened there. Let's start from this end down here. That one must have thought the topology was going off in the other direction there. So if I route that up there, he's going to end right there. That's the advantage of doing topology routing, actually, is that it will not let you route outside of that topology definition. So when I clicked on that pin, the topology was going off the other direction. It would not let me route down to these vias here. But cool little function here that you're seeing happen is called bounce around or push behind. So it knows that this trace lives on the other side of that, and I'd have to route around it. So it can route that on the back side of that and do it for me automatically. You can turn that on and off. You can do right click, and you can say push trace behind. You can turn that feature off if you don't want that to happen. But I do in this case because it'll save me time. I don't have to go back and fix that later. Drop that guy in, and then do the next one. There, it did it again for me. And then we'll do our next one. And you see there, it did it again for me. Instead of me routing around it, it took care of it automatically. All right. So now, earlier I had set up a pin pair matching constraint for these guys here. So if I come in and choose pin pairs, and I select each one of these, you can see down here in our spreadsheet window that we're getting linked information fed back to us right away. And it's currently at a yellow state, letting us know that none of those are matched within the 10 mil tolerance that I've set, okay? So what I can do here is I can select this pin pair, do a right click and hit tune, and it will automatically put tuning in for me based on the net that it finds is the longest one, okay? So instead of me going in and putting in all that serpentining work, the tool did all the work for me. Again, this, for all those customers out there using PADS Standard Plus, you have this capability to do this, okay? And then I can click on the next one and do tune. It will tune that one. When I click on it, you'll see it's green. And then if I click on this one and do the same thing again, looks like it didn't want to push and shove some stuff. So let's grab this trace segment here and pull him down. Oops. And try that again. I'm not 100% sure why it's not tuning that guy. That is quite a bit off. And choose tune on this one. There we go. All right, so now you can see the tool has tuned all of those nets for us, and Now, if I click on each one of these, you'll see they're all matched within the tolerance. In fact, they're all matched exactly based on our requirements, okay? So to control some of the serpentining that's going on there, you can go into the properties dialog box or options, click on tuning, and there's minimum amplitude that controls the minimum height of a trombone. So what the minimum is for here, then you can have a maximum, which is how big the trombone can be. There's a minimum gap between traces. You can see I have it quite large. It's 5 times the corner trace clearance. So the gap is rather big between those. And then we have what's called a hierarchy level. So you can see there's some random meandering in here. That's what controls the tool to have that capability of doing that random meandering instead of just doing a trombone flow in a linear fashion. So play around with that in doing your length matching, okay? So real quick there, I showed fanning out the design using autorouting technology. Multiple ways you can go about doing that. Using interactive routing in the tool to simplify the routing process. Yeah, granted, this is a simple example, but if it was a complex area of the design where I need to push and shove, the tool would take care of all that work for me. All right. And then we touched on doing the length matching function that's available to all customers with PAD Standard Plus, and PADS Professional can do it too. It's just done it a little different way. But all right. So that's a quick overview of what's available for some routing automation in, well, let me do a differential pair quick. I almost forgot about differential pairs. So up here at the top, I think are those differential pairs that I defined a little bit earlier. So these 2 guys right here, all right? So now if I click on the route button again, or I'll just hit F3, I can click on one of those pins and you'll see it will automatically pull out that differential pair for me, all right? Now, as soon as you see the nets gather together, you want to do a left click and continue on. So you want to be, when you route across the board, you want to make sure you have those 2 little via sites there on your trace or on the end of your cursor, okay? You don't want to continue routing when you're in this state like this, because the traces are what considered are merged together at that point, all right? So let them come out, merge together, left click, and then continue on from that point forward, okay? Now, another way to add tuning that I didn't show a little bit earlier with the single-ended traces is at any point in time in here, while I'm routing this differential pair, I can come in here and do a right click, add accordion. And I probably don't have enough room here, would be my guess. Let me back up. The accordions are going to be a little bit too big based on some of their setup I have there. So we'll come down here, add accordion. All right, so now with add accordion turned on, I can interactively go in and add tuning into my design. And I can have full control over how big the tunes are and where they're placed, okay? And then I can tell it I want to go back to regular routing. Oops. Complete accordion. And go back into regular routing and continue on, okay? Now, while the one thing I forgot to turn on while I was doing that differential pair routing to see length information, actually I didn't have a length rule constrained on here. You actually could see length information on the little heads up display right there where it says RT and ET, and also down on the status bar, down here in the status bar, it gives you length information while you're routing. But if this differential pair set had a length requirement on it, which I could go put on this one real quick actually. This was the diff 1 set, so let's go into here. Go into our diff pairs and go into diff 1, and we'll put a length on that. We'll say the minimum has to be, I don't know, 4,000, and the maximum can be 5,000. All right, go back to our layout here and synchronize. Down here in the output window, it'll tell us when it's completed the process. Here we go. Now I can go ahead and start interactively routing again. And now you can see there's a heads-up display on my cursor. Scroll across a little bit more. Heads-up display on my cursor letting me know where I am relative to the length requirement that I've set. So that helps me when I'm putting in the manual tuning to determine, how much more I need in the design. Okay. So again, a couple quick examples there of using automation in the tool to help you out with differential pairs, length matching, fanning out your design, just doing everyday routing. Again, it's so much faster and easier using interactive routing than doing point and click on everything. Just being able to come in here and draw out your nets and push and shove items out of the way just makes your job much more enjoyable and simplistic than normal. So, and then lastly, the modification stuff, I can pick up, say, a via here. I can do a right-click move or Control-E, and then I can push and shove those traces around. I can grab trace segments, set my filter for traces and pins, and I can pick that up and drag it, or I can use the stretch command. So if I do right-click stretch or can Shift-S, it will stretch. The nice thing about that is you can see when it gets to a corner, it knows, and it will either stop right there, it'll snap into that location, or unlike the move command, can do some things that aren't quite expected sometimes. So the stretch command is best to use when pushing and shoving segments around. Okay. Little things like this can be fixed easily, again, by doing Shift-S, bump that over, push that V out of the way real quick, and move on and continue. Okay. Much faster than moving all of that stuff individually. All right. Let's move on to Paths Professional real quick. A lot of this is all going to be the same in Pro as it is in Router. As far as the constraint editor system is completely the same. If I open up CES in this case, you'll see the environment looks very much the same as it did before. The advantage here is I can actually open up the stack-up editor inside of the constraint editor system, and I can define my stack-up for my design using the hyperlinks stack-up information. So I can look at Z-planning, I can do all my differential pair, single-ended impedance planning requirements in here so that I know what my trace widths need to be in the design. But this tool actually controls the stack-up for the physical board layout design, unlike the way PADS layout does it through the layout interface. All right. Another big difference here is the ability in Paths Professional to do area-based design rules. All right. So in this application, I can define areas in a given portion of the board. So like this RF circuit, I can have an area rule set up where the trace widths are wider, the spacing between the traces and planes is different, the vias being used are different. But the example I'm going to show here is actually this BGA. Okay. So right now I have an area rule around here. This is the guy right here. It's just a shape that you draw, and then you assign the area rule type to it. And then you assign a scheme to that area rule. Okay, and you can see right here I have one called FPGA. If we go back to CES, you can see I have an area rule called FPGA. So now everything in the net clearances and classes area, or everything in the net classes section will be adopted into each one of those rule areas that you create. So now I can specify different trace widths, the layers that I'm allowed to route on for that particular rule area, the vias I'm allowed to use. So here you can see I'm specifying a different via than the rest of the board to be used within that rule area, which is much more powerful than using component-based design rules, and you'll see that when I do some routing here. All right, so let's do that. Let's go back to Paths Professional. And again, if I made any design rule constraints down here in the lower left right corner of the window, that little green button is letting me know that my constraints are currently in sync because I haven't made any changes yet at this point. But if I did, I would need to double click on that guy to synchronize the constraints with my layout so the tool would start taking advantage of those. All right. So just like in Paths Router, I can select the component and I can do right click, apply a fan out pattern to that part. So this will pull up the autorouter technology that's within Expedition, Paths Professional, and it will fan out all of my traces and vias for me. Okay. Now what I set up here in this tool is when I do a fan out, I want it to automatically lock down the trace segments and vias. In Paths Router, you can't do that. You'd have to go in and group select all of them and then protect them. But in this tool here, if I go into route, fan out patterns, as you see, this is very similar to what was in Paths Router. I can choose my quadrants types, but I can say create semi-fixed objects to prevent them from possibly being moved around inadvertently. All right. So I've got that fanned out. If I scan down here, those nets are going to be going to these pins right here, which I fanned out a little bit earlier. But what I want to do here is I just want to route these address bus connections. So kind of a cool feature in Professional is all my net class information comes over into the Net Explorer function inside of Pro, and now I can use that for selecting and highlighting and finding items in my database. So this is another great reason to use classes in a design, is that you can use it purely for design review or finding objects. You don't even have to set rules on it if you don't want to. Just use it simply to group things together in the design, making your life easier. All right. But in Expedition, we have this neat feature called marking nets. So that's actually not the class I wanted to mark. I'm going to get rid of that. I wanted this one here, F data. But I can mark those, and you'll see that it will turn off everything else on my screen. So through the display control here, on objects, I can tell it that I want to, for marked nets, I want it to display only those nets and not anything else. So this can really help for a design that's very complex, really helps see what you're working on in the board, right? So let me zoom back out appropriately here now. Now what we're going to do is, instead of me just using interactive to route this, I'm going to take advantage of some auto routing technology that you get with Paths Professional that's kind of unique to Pro, actually. So in our display control here, I'm going to turn on what layer I want to route on, which in this case would be layer 2. I'm going to select all these nets again, and I'm going to use one of these this function down here called draw sketch. All right. So now what I'm going to do is I'm just going to draw a line where I want those nets to be routed. Double click at the end, and it will pull up the auto router, and it will auto route those nets in the exact location where I drew that line. Okay. Very powerful auto routing technology that's only available in Paths Professional. So now if I go to layer 5, I can grab those nets, and the rest of those nets that didn't get, oops, they were already selected. Draw sketch again, and have it go basically in the same location, but on layer 5, double click, and it will finish routing those for me. So in a couple seconds, I basically routed, those 12 nets or however many I had there in a couple seconds, and it basically did them in the fashion that I would have done it myself anyway. Okay. Now to see the area rule stuff that I was talking about, let's scroll up in here and review this real quick. So my design rules were set up to where I had a larger trace requirement outside this rule area, and on the inside I had a smaller trace requirement. So as it crossed that boundary, it automatically necked down for me to go in to that BGA. Okay. And as I stretch and pull that around, you'll see it will automatically change everything that I do. Okay. Even at a diagonal. Okay. So the tool is maintaining all of that spacing and design rule information for me automatically, and so I don't have to worry about it. Very powerful technology if you're doing fine pitch BGAs. It works for differential pairs, single-ended nets. Fanning out. You can see I used a different fan out via here for these nets than I would say outside the design. It's simplifying the whole process of designing this printed circuit board. Okay. All right. Well, we've kind of hit the bottom of the hour here. Let's go ahead and do a recap on what we've covered today. So spending a little bit of time going in and creating your design rules is going to dramatically reduce the amount of time it takes you to route a printed circuit board. It's just understanding what you want to create and how. Using class rules to your advantage is a big time saver, not only for setting up the design rules, changing them in the future, but just even also for doing design reviews, because anyone that opens that design will, using a viewer, will see those class rule assignments. All right. Using auto routing to interactively give you more control. So like I did with sketch routing there, I used full auto routing technology, but I was able to control it using the sketch feature in the application. I didn't get a chance to show it in PADS router, but you can kind of do the same thing in router. I could select a group of nets and just do right-click route, and it would auto-route just that group of nets. I can go in and clean up whatever I didn't like that it did, protect those items if I want to, or I can move on to another group and auto-route that group. That's something I used to do quite commonly, actually. And again, the constraint editor system really simplifies the process of creating design rules, and that's available to everyone out there that's using a PADS Standard Plus or PADS Professional. You do need to be in the integrated flow with Standard Plus to take advantage of that. That means you have to use PADS Designer in order to do that. For those customers using PADS Logic, unfortunately, you have to continue the way you've been doing, but hopefully you've seen what I was able to do with the interactive routing, fan out, length matching type stuff. So if you're not doing that today, please definitely in the future take advantage of that. All right. See if we have any other questions here. Can you quickly show how to add CES rules from the schematic side? Yes, I was going to show that, but I ended up talking a little bit too long. So I have a schematic open here. So here's the schematic entry for my PADS Classic Flow design. So what I need to do is just open up the Tools toolbar, and from there, when you're, again, in integrated flow, there'll be a constraint editor button here. You go ahead and click on that, and that will launch the constraint editor system, just like you see it inside of PADS Router, and you'll have all the exact same design rule constraints. Since I made design rule updates in PADS Router, I would need to use PADS Layout to synchronize back into the schematic in order to see some of those updates. All right. But yes, that can be done very easily. All right. Is there a way to auto match multiple nets all at once? So in PADS Standard Plus and in Pro, you can only do one net at a time. In fact, in Pro, I didn't get to show it, but you can only do interactive tunings. You have to click on a net and you can pull out a tune very quickly. You can push and shove additional nets around it. And in Pad's router, I showed you where you can click each individual net and have it tune that. If you want to group tune nets, you can add a feature to either one of the products. In Standard Plus, it's the multi-trace. In fact, both of them is kind of called the multi-trace option. That allows the autorouter to auto-tune multiple nets all at once. So if you have a lot of link matching to do, that is definitely a feature you would want to look at and add on to your design flow. All right. All right, well, we've gone over a little bit in our time here. I want to thank everyone for joining us today in this OASIS TriLogic webinar on Did You Know Design Rules and Automatic Routing can dramatically reduce your design flow time. All right. Thank you, and hope to see you at another one of our webinars here in the near future. Take care, everyone. Bye.